Start the recording here. This week we're going to be talking about exponents. Not real difficult stuff. I mean, there's a lot of rules with exponents. There's no question about it, that there are a lot of rules when you're dealing with exponents. So we'll be going through all of those rules. Well, we'll be reviewing them because on the lesson tutorial you should have seen them. So here are the exponent rules. We have the product rule that says if the bases are the same, we add the exponent. So if I had x to the third times, whoops, my marker's not on. X to the third times x to the eighth, our bases are the same, so I just add the exponent. So that would be x to the 11th. Another rule is the quotient rule. If the bases are the same, we subtract the exponent. So if I had x to the fifth over x to the second, I would end up with x to the third because I just subtract 5 minus 2. The zero exponent property says anything raised to the 0 power is 1. Now, I will tell you that a lot of students will make a mistake this week on the assessment because I know where kids make their mistakes, so I put problems in there that will, let's say, make it so you don't get an A+. So, for example, here's a problem that using the zero product property I could give you. I could give you something like 2 times 3 to the 0 power. What would my answer be there? And remember, anything raised to the 0 power is 1. So what's my answer? You guys are right. The 0 only goes to the 3. So this would really be 2 times 1, which is 2. Now, what if I gave you this? What if I gave you 2 times 3 to the 0 power? Then what would my answer be? Now, right, it would be 1 because now it's just the exponent goes to both of those terms. So it would be just 1. Good. The power rule says that if I have a power to a power, I multiply the exponents. So if I add x to the third to the second power, I multiply these exponents, and I would get x to the 6th power. If I have 3 to the second to the 4th power, multiply it out, I get 3 to the 8th power. So those are exponent rules that you will need to know this week for the assessment. I saw that. All right. Now, when you have parentheses, it really makes a difference. Okay? So this is called the expanded power rule. If you have something like 2a to the 3rd power, that exponent goes to the two factors inside the parentheses. So that would be 2 to the 3rd times a to the 3rd. Okay, that 3 goes to both of them. If I had something like 6x to the 3rd to the 2nd, well, that's going to be 6 to the 2nd times x to the 3 times 2, which is to the 6th power. So you have to be really careful when you have parentheses and you have a power out there, because that power is going to go to all of them. Okay, so be very, very careful. Then we have 2 formulas this week. We have a formula for compounded interest. That formula is the amount of money that you put in, 1 plus the rate over the number of times you're going to compound, raised to the nth power. And the other one is compounding continuously, which we call the PERT formula, the amount that you put in times e to the RT. So let me give you an example. Let's say I gave you $10,000, or you had $10,000, and you're going to put it into a savings account that's compounded monthly. Okay, so it's compounded monthly, and you're going to leave it in, and at an interest rate, let's say the rate is 5%, and you're going to leave it in for 10 years. How much money would you have at the end of the 10 years? Okay, and then I'm going to say that you have the exact same thing, that you have $10,000, and it's compounded continuously at a rate of 5% for 10 years. Okay, so, oops, that's not percent, that's years. So you're going to have to use 2 different formulas. For the first problem, I'm going to have to use this formula. My n value is 12, because that's the number of times I'm compounding it. My rate, okay, Now remember, you have to change a percent to a decimal, so that's 0.05. And then my t-value is 10 years, and this is my p-value, which is the original amount. So I'd plug that in. I'd go 10,000 times, and then 1 plus, and then my rate is 0.05 over 12. All raised to the 12 times 10, because it's n times c, so that'd be to the 120th power. Now, I don't have my good calculator here. I just have this cheaper one. So let me figure out what that value would be. Okay, so I have 1 plus 0.05 divided by 12. And then I'm going to raise that to the 120th power. And then I'm going to multiply it by 10,000. Okay. And I come up with, no, my calculator's, as I said, my calculator's a piece of junk. It's not even a, okay, I'm going to try this again. Divided by 12. Okay, and then I'm going to raise that to the 120th power. Okay. I get like 1.647, and then I'm going to multiply this by 10,000. Hopefully my calculator works this out. Okay. 16,470. Okay. 16,470.09. All right. Now, if I was going to use the same thing, but it's continuously compounded, I'd use this PERT formula. So this is going to be P, E, R, T. Now, E is like 2.71. Your calculator should have an E button to it. So if I did this problem, it would be 10,000 E, and then RT, so that's 0.05 times 10. Now, my calculator is so cheap, it doesn't even have an E button on it. So can somebody multiply that out for me? What is 10,000 times E raised to the 0.05 times 10? Now, I know it's going to be really close to this. It's going to be a little bit more because when you compound continuously, you will get a little bit more there. So my answer should be, okay, so 16,487, or I'm sorry, 16,487. So this should be my answer if it's continuous. So make sure when you do the last problem, or maybe it's number 3, I'm not exactly sure which one it is, but one of the problems, one of the last problems tonight on the assessment deals with continuous compounded and continuous finding the value. So just make sure if it's continuous, you use the PERT formula. If it's just a normal, compounded monthly or something like that, that you use the first formula. All right. Okay. So now let's get into this week's practice. So I'm going to give you guys the session code here. I need to copy that. Okay, so here we go. All right, so can you guys jump into the Desmos presentation, and then we will work through the problems for this week, the practice problems for this week, and I think you guys are going to have a pretty easy time with it. Let me, I have to share, let's see here, so I've got to share this. All right. So the first thing we want to do is we want to go to slide number 3, okay? Oh, I didn't even talk about negative exponents. Shame on me. All right, so negative exponents. So we're on slide number 3. The first problem says, and when you simplify something, you cannot have negative exponents, okay? That's a no-no. So in this problem, it says, write the expression with only positive exponents, assume all variables represent non-zero numbers, simplify if necessary. So they have 5x to the negative second power. What's my answer? And you guys can just put in the chat box what you think the answer would be. Letter C. How come it's not letter A? Why wouldn't my answer be letter A? I'm looking at letter A and it looks pretty good, doesn't it? Why isn't letter A correct? Because the exponent only goes to the x. That is absolutely correct. So in this problem, I've got 5x to the negative second power. then negative second power only goes to this x. So that's the only thing. Now remember, when you have negative exponents, if it's in the denominator, it brings it up to the numerator. If it's in the numerator, it brings it to the denominator. So I'm just going to rewrite this as 5 over x squared. Pretty easy. Awesome. All right, let's go to slide number 4. Uh-oh, a word problem. No, Mr. Shanklin, not a word problem. Okay, in this word problem, it just asks you, it says, which expression shows the value of a $2,500 investment after it has grown by 4.5% per year for 12 years? Okay, so now, this is where it gets a little bit wonky. They don't tell us how many times it's being compounded, okay? So if that's the case, if you don't know how many times it's being compounded, or if it's, you know, growth by year, then it's really just one time. So instead of using this formula, P1 plus R over N to the NT power, if N is 1, if you're only compounding this, and if they don't tell you, you just assume that it's being compounded once. If it says continuously growing, then you use the PERT formula. But in this problem, if you don't know how many times it's being compounded, you just assume it to be 1. Well, if you assume this to be 1, isn't this formula the same as this formula right here? If N is 1, then this formula here, this compounding this compounding formula just turns into this. So in this problem, I've got my original value is 2,500, 1 plus my interest, so that's 0.045, and after 12 years, so then if I rewrite this, I've got 2,500 and then 1.045 to the 12th power. Okay, so that compounding, if it's just compounded once a year, then we can use that simpler formula, P times 1 plus R to the T power. Okay, so be very careful on that one. But if it says continuous, we have to use the PERT formula. I love the PERT formula. All right, so my answer should be what, letter A for this one? All right. So now I'd like you guys to go to slide number 5. And I'm going to let you guys do this problem yourself. It says apply the quotient rule for the exponents if applicable and write the result using only positive exponents. All right, so I have x to the negative 16th over x to the negative 4th. What should my answer be simplified down? And there's not a lot of work in some of these problems this week. The practice should be, you'll notice that the practice and the assessment this week is fairly easy. There's not a whole lot of work. I mean, most of you can just look at that and say, okay, I've got x to the negative 16th. I put that in the bottom. I put x to the 4th in the top. If I simplify that down, I get 1 over x to the 12th, which is letter A. So not a whole lot of work, and you don't really have to show much work this week at all in the assessment, because most of them you'll be able to do in your head. All right, let's go to the next slide here, which is slide number 6. Again, it says simplify the expression, no negative exponents. All right, so what would your answer be here if there's no negative exponents in there? Letter A. Letter A. Let's see here. So I've got that x to the 10th, bring it to the bottom. X. Yes, I agree. Letter A is correct. Awesome. All right. Next problem on the practice this week. No, Mr. Shanklin, you didn't give us such an easy problem. What's my answer? Again, there really isn't any work here. Yes, it is B. All right. So not a real difficult. As I said, the practice is not tough. The assessment is not tough either. I mean, you guys should have a pretty easy time this week. All right. Next problem. Oh no. What? This does not look like it should be on this week's assessment. Solving. Did I? Wait. Let me jump into the assessment this week. I thought that was next week, solving exponential functions. All right. Why did that make it in there? Let's see here. Lessons, week 3. Huh. Oh, I guess solving one-to-one equations. Is that part of it? Oh, it is. Oh, sorry about that. I didn't know that we were solving exponential. Number 3 on the assessment. Okay, so let's review how to solve exponential equations if we can write them with common basis. Okay, so 4 I can rewrite as 2 to the second, can I? And 32 I can write as 2 to the 5th. If you can write the exponent with common basis, okay, so in this problem I have 4 and then 4x minus 1. Well, in place of the 4, I'm going to put 2 to the second power. So I'm going to have 2 to the second power, but I still have that 4x minus 1 here. And then over here is equal to, I've got 32 to the 2x minus 1. Well, in place of 32, I'm going to put 2 to the 5th. But I still have the 2x minus 1. Now, if the bases are the same, the exponents are equal. So I know that the bases are the same. So I know that 2 times 4x minus 1 is equal to 5 2x minus 1. So now I have to solve this equation. So I'm going to multiply through by 2, so that gives me 8x minus 2 is equal to 10x minus 5. I'm going to subtract 8x off of both sides. I'm running out of room here, guys. All right. So that leaves me with what? And I'm going to add 5 to both sides right away so I can get rid of that. And so I end up with 2x equals 3, I think. 2x equals 3. I think that's right. And then I'm going to divide through by 2. So x equals 3/2. All right. Any questions on that? That was a lot there. Any questions on that? Something that you guys didn't understand? But the key is you have to get common bases. If you can't get common bases, then we have to use logarithms to solve. But that's not for a couple more weeks before we do that kind of stuff. All right. So this one is basically just try every problem that you'll see on the assessment will have a common. You'll be able to rewrite it with a common base. All right. Let's go to the next problem on the practice. All right. So this one I am going to let you guys work on. I'm going to turn off my mic because I hear my dog whining. He's outside. So I'm going to turn off my mic. I'm going to let you guys do this problem and see if you can get it. This one's a little tricky, but you should be able to get it. All right. So I'm going to turn off my mic, let you guys do it. All right. Did anybody get the answer to this one? As I said, it's a little bit more difficult. B with a question mark. All right. Well, let's take a look. The first thing I would do is I would try to get the bases to be the same. Okay, so it's like, okay, how am I going to do that? Well, I'm gonna write 4. I'm going to write 0.5 as 1/2. 4 I can write as 2 to the second. 1/2 I can write as 2 to the negative 1, can't I? Isn't that the same thing? So now I have common bases. But I still have, this would be 2 and then 2x minus 5. And this would be 2 and then negative 1 to the 2x minus, or 2 minus 2x. Okay, so I've got a common base, so that's going to give me 4x minus 10 is equal to negative 2 plus 2x. Subtract 2x from both sides. So 2x minus 10 is equal to negative 2. Add 10 to both sides. 2x equals 8. X equals 4. Oh, that is letter B. Very nice. Any questions on that? That was and the tricky part to these is being able to come up with a common base. So you have to be able to look at it and say, okay, how can I rewrite 4 and 1/2 with a common base there? And once you do that, then it's not so bad. Okay. All right. Let's try the next problem off this week's practice. Oh my goodness. Oh, I can barely read that. All right. Let me get my bifocals on here. Oh boy, let me see if I can get my screen any bigger here. Is that okay? I can make this. Okay. Suppose K inherits $250,000, which he invests today at a rate of return of 9% compounded annually. That means one time a year. How much will K's investment be worth in 25 years? All right, so if I was going to do this problem, first thing I'm going to do is I'm going to say my p-value is equal to $250,000. Wish I would inherit $250,000. It's $250,000. Rate is 9%, so 0.09. And this is going to be, my t-value is going to be 25 years, and it's compounded annually. That means one time a year. So that means I can use this formula, P1 plus R to the T. So that's going to be 250,000, extra 0 there, times 1 plus 0.09, which would be 1.09 to the 25th power. Oof. It's going to be a lot of money, because when this number gets high, when the time, because it's an exponential function, that means it's going to get way up there, and that's where the money starts growing really fast. All right, so what I'd like you guys to do is take your calculator out, because my calculator is not going to go up that high. I can guarantee you that. I've got just a cheapo one. Okay, so what should my answer be? And I mean, I can't even take a wild guess here, because I know it's going to be huge. There's no question about that. All right, I got to jump back to see what letter B. Is that correct? As I said, my calculator is not going to do it, but I know that 9%, 25 years. Usually a good rule of thumb is that 7%, 7 years doubles your money. Well, this is 9% at 25 years. That's going to more than 4 times. It's going to be more than 4 times its average. So yeah, that thing is going to grow fast. So you guys are saying the answer is B? All right. I will go along with you guys. All right, next question on the practice. We have 2 to the x is equal to 1 over 16. All right, what's my answer there? I can make my screen smaller now because I had to make it really big so I could read that last answer. 4, negative 4 for my answer, letter B. And there's not a whole lot of work to do on this one. You can just look at it and say, okay, 2 to the negative 4th power is 1 over 2 to the 4th, which is 1 over 16. So yes, that is correct. I agree with that. All right. I don't think I have anything for the assessment. Okay, so on the assessment this week, problem number 1, I give you like 6 problems just like this, okay? What are my 2 answers here? And I believe these are 2 problems right off the assessment today. So what would you give me for answers for parts A and B for the assessment this week? And these are 2 problems right off there. And what would my answers be? All right, so it looks like Arnish, I see your answers are correct on the, get your answers there, good. X to the 13th and 4x to the 6th, I agree. And Arnish, you had them already worked out in decimals, excellent, very good. So the assessment starts off fairly easy this week. How about the second type of problem on the assessment this week? Solve. And I think there's like 5 problems here where it says solve the equations. Okay, what is x equal to here? You probably could do it in your head. I mean, it's probably not a real difficult problem. A couple of them get a little bit more difficult. So what would my answer be here? 3 to the x plus 1 is equal to 27. What does x equal? X equals 2. I agree. Now, you should be able to do it just in your head. But if I was going to do this problem algebraically, I'd rewrite this as 3 to the x plus 1 is equal to, well, 27 is the same thing as 3 to the 3rd power. If the bases are the same, then the exponents are equal. So this would just be x plus 1 equals 3, x equals 2. All right. I think I have one more slide. What does m equal for this problem? What does m equal? M equals 0. Oh, is that right? 6. So that would be 6 to the 2n equals 6 to the negative 2m. So 0. Yeah, that is correct. All right. That is it for this week. Any questions on any of the stuff that we went over today? As I said, this is probably one of the easier weeks this week. Dealing with exponents, you shouldn't have too many problems. All right. You guys have a great week and stay inside. It is awfully cold out there. Bye.